Hello, welcome back to our Java programming series, topic number 24, Java Recursion. Please do not forget to subscribe and ring the bell so that you could get the latest videos of SirParts online. And let's proceed now to our new topic, Java Recursion. Okay, so Java Recursion. So recursion is the technique of making a function call itself. This technique provides a way to break complicated problems down into simple problems which are easier to solve. Recursion may be a bit difficult to understand. The best way to figure out how it works is to experiment with it. So we have here our example. Adding two numbers together is easy to do, but adding a range of numbers is more complicated. So in the following example, recursion is used to add a range of numbers together by breaking it down into a simple task of adding two numbers. So this is now our code for that particular problem. The name of our program is recursion code, and we save that as recursion.java. And this is our main method, and we declare a variable result with a data type of integer, and we use the method sum with an argument value of 10. So this is now our method sum, wherein we use another method here, another parameter, integer k. So if k is greater than 0, it will return k plus the method sum k minus 1. So else it will return 0. So let's try to run this particular program. So we're gonna edit or run. Recursion code.java. Here recursion, then save, then run the program. Okay, there's an error. Okay, duplicate plus recursion code. Maybe we were not able to write the. Let's try to look at the other problems here. Yeah, this one we were not able to. That's a duplicate recursion code. We're going to the comments here, and let's try to save and run the program. We click run. Here you go. You have 55. Okay, so for explanation, when the sum function is called, it adds parameter k to the sum of all numbers smaller than k and returns the result. When k becomes 0, the function just returns 0. So these are like 10 plus sum of 9. Then after that, 10 plus 9 plus sum of 8. It adds until such time that you have this one. You add all the numbers 10, 9, 8 until 0. Since k is 0, the program stops there and returns the result. So that's why we produces the output of 55 for that particular problem. So if you want to add, that is to add all numbers starting from 10. So if you want to add numbers starting from, let's say for example 20, 20, so you just change this one to 20, and you can have all the sum of all the numbers 20 below. Let's try to run the code. Here you go, 200 and numbers 20 plus 19 plus 18 plus 17 plus 16 plus 15 until plus 50. So let's continue. So let's try to disable this code, adding multi-line comments. And we have here the halting condition, no? So halting condition. Just as loops can run into the problem of infinite looping. So when you say infinite looping, it loops back, it continues to loop, no? And it's a problem, no? It's a problem. Recursive functions can run into the problem of infinite recursion. Infinite recursion is when the function never stops calling itself. So every recursive function should have a halting condition, which is the condition where the function stops calling itself. So in the previous example, the halting condition is when the parameter k becomes 0. So it is helpful to see a variety of different examples to better understand the concept. So in this example, the function adds a range of numbers between a start and an end. The halting condition for this recursive function is when end is not greater than start. So let's try to see the example. So let's say this is our example. Use recursion to add all numbers between 5 and 10. So this is our code. So same, the name of our code is recursion code. And then we have our main method. And we have two arguments here, the 5 and 10, no? These are arguments. This is our method sum. So this is our method sum. We just call it here. We just called that, and we display the result. So here is our method sum, wherein there are two parameters. They are all integers, the start and the end. So here there's an if end is greater than start, return end, plus sum sa start, then end minus 1, else return end. So this one, our value for our start is 5. So if 5 10, that's our end, no? If 10 is greater than start, which is 5, so this will execute. It will return, no? To return end, the value of our end is 10, and the sum of start 5. This is now our, we call again our function. That's where the recursion happens, no? Because this start will be the 5, and then this one, the value of this one is 10 minus 1. That's 5 and 9. And else, if this is the true, it will return end. So let's try to run the code and see the result. Okay, so we have there 45. So numbers 5 to 10, if you add it up, that is 45. So things you're going to watch out on this recursion is that this one, the developer should be very careful with recursion, as it can be quite easy to slip into writing a function which never terminates, or one that uses excess amounts of memory or processor power. However, when written correctly, recursion can be a very efficient and mathematically elegant approach to programming. So thank you very much for watching. I hope you learned something today about recursion, and we are already in topic number 24. I'm very happy. I hope you already make the codes here in our Java programming. And if you have problems with the codes, please feel free to comment so that we could give you some tips, no, or can help you in making your codes a good one. So thank you very much for watching, and always remember, learning is lifetime. See you in our next topics. Bye everyone.